Okay, so we're doing 2.6 multiplying and dividing rational expressions. These are the steps to multiplying and dividing rational expressions. To multiply them, the first thing we're going to do is factor both numerator and denominator. The second thing is we're going to state restrictions. And you learned about restrictions on the last lesson. The bottom, or the denominators, cannot be 0, so that's what we state for restrictions. Then, the only other new step is you're going to multiply the numerators and multiply the denominators together, and then divide by common factors. So just as a reminder, when we go to multiply two fractions together, the way we do that, regardless of the factoring and all that, the way we do that is we multiply the tops together, so 3 times 2, and we multiply the bottoms over here together, 5 times 3. So we end up with 3 times 2 on the top, 5 times 3 on the bottom. Of course, you can cancel out the 3's, because they're factors, all multiplication, division, and you're just left with 2/5. So this is going on the same type of premises for doing all of these things. The factoring is what you do first, and then you do the multiplication, the restrictions and multiplication second. So let's take a look at this. Example 1, simplify this and state any restrictions. We don't have to say state any restrictions, you should always state restrictions. So let's take a look at this. So let's factor this. Well, let's take a look at the top here, 6a cubed. Well, that's just one term. I cannot factor that, so that stays as is. The bottom is 4b. I can't factor that either. The top of this thing, 8b cubed, I can't factor that, and 9a to the power 5. These are all monomials. Can't factor these things, so it's already all factored for us. So then I state restrictions. So stating restrictions, the bottoms or the denominators cannot equal 0. So from this bottom, that 4b cannot equal 0. That just means, if I divide out the 4 from both sides, that means b cannot equal 0. If b is 0 in this question, that makes this question undefined or impossible to do, because the bottom of any fraction cannot be 0. Then this last one here, 9a to the power 5, that cannot equal 0. Well, if you divide out the 9 from both sides, you're going to get a to the power 5 cannot equal 0. We haven't discussed fifth roots as of yet, doing the fifth roots, cubed roots, square roots, and all that. But from this, you can only imagine that just a cannot equal 0. Because think about it, if a was 0, this would be a to the power of 0 to the power 5, which is 0 times 9, which will make that 0. So you cannot have, a cannot be 0. That will make the question undefined as well. So those are restrictions. B cannot equal 0, a cannot equal 0. And then step 3 is multiply the numerators times the numerators. So I got 6a cubed times 8b cubed. So multiply 6 times 8, that's 48. And a cubed times b cubed is a cubed b cubed. And on the bottom, I have 4b times 9a to the power 5. 4 times 9 is 36. And I'm going to write the a first, a to the power 5, and just b. So both top and bottom between the numbers are divisible by 12 if you're not using a calculator. That divided by 12 will leave me with 4, and that divided by 12 will leave me with 3. So it's actually 4/3 if you used your calculator. Then, let's take a look at a to the power 3 divided by a to the power 5. When you do that, there are more a's on the bottom than there are at the top. So if you try to cancel out a's, there's going to be 2 more on the bottom than there are at the top. So when you cancel them out, if you try to cancel these out, there's going to be a squared left on the bottom. There are 2 more left on the bottom than there are at the top. Same with this. This is b cubed divided by b to the power of 1. Again, there are 2 more b's on the top than there are on the bottom. So when you cancel these things out, at the top, you will be left with b squared. And this is my final answer. Now this is a little different. These are all monomials. It's just a monomial over a monomial. But our next example will be more geared towards the factoring. So when I take a look at this next example too, and it's multiplication, that's a multiplication there. Now in your textbook they may have x there, or they may have a little dot. A dot is still multiplication. So I have this trinomial x squared plus x minus 6 on the bottom. On the top, on the bottom I have x squared plus 2x minus 15, and I'm multiplying by x minus 3 all over x minus 2. So the first step is always factor. Factor everything. So that's what I'm going to do. Now if I take a look at these are already factored on this. This is just a binomial, x minus 3. And I'll write it in brackets. and the other one is x minus 2. I'll write that in brackets as well. Those are already factored for us. Now the top of this one I can factor, because the top of that one is just a simple trinomial. Again, they can be complex trinomials. So using complex trinomials, it's going to suck if you try to use decomposition to put them back into the question. Take them off to the side, use decomposition. I would clearly try to use the crisscross method, as you have videos on my playlist there about the crisscross method. But the product of this thing is -6, the sum of this thing is 1, and two integers that multiply to -6 but add to 1 are -2 and 3. -2 times 3 is -6, -2 plus 3 is 1. So my two brackets are x minus 2 and x plus 3. So I have factored that. And the next one, I have x squared plus 2x minus 15. I'm going to use product sum integer rule on that one as well, because that's a simple trinomial. So the product of that thing is -15. The sum of that thing is 2. So the two numbers are -3 and 5. -3 times 5 is that, -3 plus 5 is 2. So my two brackets will be x minus 3 and x plus 5. So I have factored everything. That is step number 1. Step number 2 is state all of the restrictions. So now off to the side, I have to state all my restrictions. So the restrictions are, none of the factors on the bottom can be equal to 0. Just on the denominator. The numerator, it doesn't matter. The denominator only. So that first one, x minus 3, that cannot equal 0. And that means x cannot equal positive 3. So that's my first restriction. Because if x was equal to 3, that'd be 3 minus 3, which is 0. 0 times 0 times anything is 0. That'll make the bracket 0. The bottom, the denominator 0, and that's no good. So the x plus 5, that cannot equal 0. That means x cannot equal -5. And then the x minus 2, that cannot equal 0. And that means x cannot equal positive 2. So these are my three restrictions. You get 1 mark for stating the restrictions. You either have it completely right or completely wrong. If you added too many, like if, for instance, you've said x plus 3 cannot equal 0, therefore x cannot equal -3, that would have made all of your restrictions wrong, because x being -3 is totally fine. The numerators can be a 0. You just cannot divide by 0. So then continuing this, the next step, so multiply all the numerators with the numerators, all the denominators with the denominators, leave them in the brackets, so I'm going to write straight across x minus 2, x plus 3 times x minus 3, because that's how you multiply fractions. Multiply the numerators and multiply the denominators. So then I have x minus 3, x plus 5, and times x minus 2. And that is step 3. The next step is cancel out any common factors. Again, this is all multiplication on the top and all multiplication on the bottom. Bracket times a bracket times a bracket. So factor times a factor times a factor. I can cancel out this x minus 2 divided by x minus 2 is just 1. Again, we're allowed to cancel out because division or multiplication, that doesn't matter which comes first. And then x minus 3 can be canceled with x minus 3. So on the top, I am left with x plus 3. And the bottom, I'm left with x plus 5. The correct way of writing this is without the brackets now, so the x plus 3 on the top, all over x plus 5 on the bottom. So this is my final answer. Now some of you, and I've seen this common mistake, some of you may say, oh, well sir, can you not now divide out the x's? X divided by x? And that is, no, you cannot do that, because now this is not written as factors. This is actually a binomial at the top. There's an addition sign between these two things. There's an addition sign between these two things. You cannot cancel out unless it is multiplication and it's just factor times another factor times another factor. That's why we were able to cancel things out. Now we're not, because this is not a factor times, this is not x times 3 and x times 5. It's x plus 3 and x plus 5. So you can't cancel out the x's. And of course you can try a number there to see if you're correct on that or not. Any number for x. So that takes care of multiplying two fractions that have trinomials in them. Now we have to take a look at division. Now division, It's just a little different, not much. But if you remember how to divide fractions, hopefully you remember that. It says to divide rational expressions, the first thing you do, again, is factor the both numerator and the denominator. The second thing always is state the restrictions. Now it says both denominators, you're going to state obviously, and the second fraction's numerator. Why? Because it becomes the denominator. If you remember, and I'll come to this before we go to step 3, if you remember how to divide two fractions, over here I have 4/7 divided by 4/5. The way you were taught to do this is you keep the first fraction the same, 4/7, and you multiply by the reciprocal. So this ends up being 4/7 multiplied by 5/4. Now, as you can see, the numerator of the second fraction becomes the denominator. So then you carry on as normal. 4 times 5 is 4 times 5. 7 times 4 is 7 times 4. You can cancel out the 4's, and you'll end up with 5/7. So again, state the restrictions. Remember, no denominator can ever equal 0. So the bottom of a fraction can never equal 0. So that includes both denominators at the start of the problem. And then within the problem, that second numerator becomes the denominator. So that also cannot equal 0. So we'll talk about that when we get to a question. Change the division sign to a multiplication sign and flip the second fraction. So multiply by the reciprocal. And then step 4, multiply the numerators and multiply the denominators because it becomes a simple multiplication problem after that. And then divide by common factors.